Hello, I'm Mr. Singleton, one of the Associate Directors for Science for Outward Academy, and this lesson that we are doing about today is just these last little bits from the specification. So it's this bit about falling freely under gravity here, and this bit about falling through a fluid. The previous lessons we've talked about is this bit on the specification about acceleration. So we're just looking at this bit here about falling under gravity in this lesson and falling in a fluid, and something at this bit here which is really important called terminal velocity. If you haven't already done the other lessons, then please make sure you have completed these lessons. This is kind of the last lesson of this section of lessons about forces. So what I want you to do is make sure that you are well away from any distractions. Make sure you've got a pen and paper ready and have a think about this one. How come cats can jump out of really tall buildings like flats and things like that and they won't actually die, they will survive? How come that is? Why do they not, end up splattered on the floor? So I'll give you 30 seconds, off you go. Okay, we're going to come back to this during the lesson to see what you've got, and we'll see if you are right. So on your piece of paper, or if you are in school, in your books, you need the date underlined and the title, Falling Under Gravity. I'll give you 1 minute, off you go. Okay, so our challenge today is define what terminal velocity is, and then we are going to look at describing the factors that affect terminal velocity. And now our aspire is to explain the factors that affect terminal velocity on an object. So I just want to recap this bit here on what weight is. It's something that people get very confused about because we use it wrong nearly every day. So what are the units for weight? What is a weight an example of? Does weight have both size and direction? And what causes weight? So 1, 2, 3, and 4, a couple of words for answering these ones. I'll give you 1 minute, off you go. Okay, let's go through some answers then. So remember that weight is a force. Okay, so it's not measured in kilograms, that's your mass. So as you step on those scales in the morning, then you are measuring your mass, not your weight. Weight is a force and it's measured in newtons. Mass is how much of stuff there is of you, and that's measured in kilograms. If you ever struggle with this, you've got to think about when people go into space, they become weightless. All right, they don't suddenly end up not having any mass anymore. They don't suddenly end up, you know, having a mass of 0. They become weightless because there's a force of gravity on there as well. Does it have both size and direction? Well, yes, it does, because it depends on the gravity that's there. And what causes weight is the gravitational pull of the Earth, or if they're talking about the moon, then of the moon. And again, please remember the moon does have some gravity, just has less gravity than the Earth. All right, please keep that to the front of your mind on all of these things. It's a really common mistake that weight is measured in kilograms. It's not, it's a force, it's measured in newtons. Now, you have done a little bit in year 9 on distance time graphs. And we have also done in this section of lessons something on velocity time graph. So this is a velocity time graph for something called terminal velocity. I want you to have a think about these questions here, because I shouldn't need to give you too much away, although I have just given you a couple of answers away just to help you. But using this as just a velocity time graph, using your knowledge from your previous lessons, what do each of these bits represent? So what type of graph is it? Well, as long as you've been listening and you can read the front, the title of this slide, then you should know what that is. What does the gradient of the line then represent? Well, think back into the previous lessons. Which one shows a constant acceleration? Which one shows non-constant acceleration? And which one shows a constant speed? Okay, remembering it's a velocity time graph and not a distance time graph. All right, I'll let you have 3 minutes to answer those questions. Off you go. You've got 1 more minute. Okay, let's go through some of these answers. So it's a velocity time graph. You can find that out by looking at the y and x axes there. The gradient of the line shows acceleration on this type of graph. So where is it showing constant acceleration? That's when the line is the gradient's at a constant increase. So that's A to B. Where is it non-constant? Well, that's when the acceleration is changing constantly. So that would be a curve in the line. So that is B to C. And then where you've got a constant speed, that's where the velocity is constant. That would be C to D. Now I've labelled there, look, terminal velocity. So we're going to discuss that a little bit more. I want you to have a think about sketching and labelling a velocity time graph for a falling parachutist. So how will that look? What happens to the acceleration of that parachutist? And then what happens at the end? Now this just needs to be a quick sketch graph. If you are in school, you can just do this on a whiteboard on the back of your planner. Or if you're at home, then you can just do it quickly on a piece of paper. Don't worry about it being wrong, or have a think about what it would look like. Sketch graph, all you need is the axes labeled. You don't need to plot little points. You just need to get the kind of idea of the line. Now, if you can, think about how that person would fall. And then once they open the parachute, what happens as well. That's a little bit of an extension there. So I'll give you just 30 seconds. It's a very quick sketch graph to do that. Off you go. Right, we shouldn't be too worried about if this is wrong or anything. This is just having. So if you have thought about this very, very carefully, then hopefully what you've got is a graph which looks something like this for the first bit of it. As you jump out of your aeroplane, what will happen is your speed will increase. You will accelerate. And you'll accelerate and accelerate and accelerate. Hopefully that's pretty obvious. As you jump out of an airplane, you will fall to the floor faster. Well, why do you fall to the floor faster? It's because your weight is much larger than the air resistance pushing up against you. So you will accelerate. You've got an unbalanced force there. And then what happens is, and this is a more interesting bit, you hit something called terminal velocity, and you won't actually speed up any faster. You will go at around about 54 meters per second. So you jump out of your aeroplane, you will increase in speed, that's this bit here, you will accelerate, and then eventually you'll hit a speed and you won't fall any faster. So if I jump out of an aeroplane at about 30,000 feet, I will hit terminal velocity and fall around about 54 meters per second. If I jumped out of the airplane at 50,000 feet, same thing, I would probably hit the ground at around about 54 meters per second because I hit my terminal velocity. So this first bit is speed increases, all right, and then this bit here is called terminal velocity. Now, hopefully you jump out of the airplane and you have a parachute on, and obviously what a parachute does is it slows you down, okay? So it will slow you down, you will decelerate, all right, because it's catching more air resistance. However, even once again with this parachute, you will hit this bit here, which is a new terminal velocity. Now that is much, much lower than your terminal velocity when you didn't have your parachute. I think it's around about 12 meters per second. Still pretty fast, but fast enough where you're not going to, hurt yourself. So you will get a new terminal velocity, and then actually what would happen is you would hit the ground. So the parachute opens, and then you get a new terminal velocity, and eventually you'll get to zero velocity, 0 meters per second, because you have actually landed and hit the ground. So that is what a velocity time graph looks like for a parachute. And it's these bits here, this terminal velocity, the fastest you can fall to the ground, which are important. I'm going to talk about why that happens on this next slide. So here is my skydiver. Okay, and I'll put some pictures on the side here. So here's my skydiver, and as always when we're drawing diagrams about forces, we put arrows Please remember, the bigger the arrow, the larger the force. So here is my skydiver again, and now he has some other arrows on. So at the start of the jump, his air resistance, at the very start of this jump, his air resistance is 0. So he's going to accelerate downwards because his weight is, whatever your weight is at that point in time, depending on how much mass you've got. However, as you are speeding through the air, your air resistance increases. So the faster you go, the higher your air resistance will be. And eventually you go so fast that the air resistance is equal to his weight. And again, we've got that thing where forces are now balanced. Once forces are balanced, they travel at the same speed, or if they're not moving, then they stay stationary. But in terms of this one, once these forces are balanced, they hit something called terminal velocity. So terminal velocity, looking at that challenge, define terminal velocity, is when air resistance is equal to weight, so the forces are balanced and the speed becomes constant. I'm going to let you write that down in your books or on your paper. I'll give you 2 minutes. Off you go. Okay, if you need to pause this because you haven't quite got this down, then please pause the video now. I'm going to move on with the rest of the lesson. So still onto the skydiver, and this time he or she has opened their parachutes. Lucky for them. Now their weight is still pulling them down to the ground. Their weight is always pulling them down to the ground, and they will never fly upwards. Like sometimes you see on videos, you think that they move upwards or they suddenly stop in midair or anything. It only looks like they're going upwards because the other person filming them is still flying down to the ground much faster than they are. So when you open your parachute, you're still falling to the ground. Please remember that. They don't magically, become a helium balloon and float upwards. It just looks like that because the person filming them is traveling much faster than them. Now, the air resistance when that parachute is open is much larger than the weight. This means then that it will cause him to slow down, it'll decelerate, and that's why we have that line coming down on that velocity time graph. But then again, what happens is as he slows down, the air resistance increases because he's going slower, and then his weight and the air resistance will be balanced. He is going to go at a constant speed because they are balanced forces, but he's reached a new, or she has reached a new lower terminal velocity. So that is the lesson really. We've talked about what terminal velocity is. We've talked about the factors that affect terminal velocity. So that is the parachute will affect its terminal velocity. Just anything that will increase his air resistance. And then how that affects it, so explain it. Well, why does a parachute affect it? It's because it takes more of the it takes more air resistance. So we're going to look at the plenary now, and this is one of those 6-mark questions. I'm going to scaffold this a little bit for you though, just to help you out before you start writing it. So please don't start writing the answer straight away. The question is one of these 6-mark questions. Okay, and it says describe, remember that's one of the command words, so you've got to describe the motion of a skydiver and you've got to explain it. Okay, so describe and explain the motion of a skydiver as they fall from the plane to the ground, and talk about the individual forces acting as well as the resultant force. And if the exam question ever says drawing a graph or leaves you a nice space for drawing a graph, then please draw a graph. It will really help you. Okay, so we are going to look at this question and then have a think a little bit about how would a marble falling through a cylinder of syrup, how would that change and how would that move? So I'm going to help you here. So this is the graph that you should draw. Okay, so that I would always draw this graph in this 6-mark question, and then you can just start to label it, and you just need to be able to talk about, really it is just talking about velocity time graphs again, but also and then including the words terminal velocity when that speed is constant. Okay, so this is the shape that you need to remember. All right, I'm not going to leave it on for much longer than this, but this is the shape that you need to remember for a terminal velocity question. I'll give you another 30 seconds just in case you are just sketching that down quickly. Okay, and again, I'm going to help you out a little bit here. This is the mark scheme. Now the mark scheme is very similar for describe and explain questions. The mark scheme is always very similar in terms of how they give you marks. All right, there's little bits in here that would change obviously. So if you don't make any reference to anything at all, you're going to get 0 marks. Then it's banded, so you get this level 1. So if you write loads and loads of stuff, but there's only a brief attempt to explain why velocity or speed changes, then you're only going to get a maximum of 2 marks. So sometimes when I'm marking people's work and I put like a couple of, I might put like 6 ticks on it, but I'll only give them 2 marks. That's because I've put lots of stuff in, but it's not explained it properly. So you just have to be very careful with it. Level 2, all right, marks, which is 3 to 4 marks. So the maximum you get is a 3 to 4 marks. You have to start to explain and use some science in there. So you have to use forces. And then level 3, which is over the top, is 5 to 6 marks. And for every single question that's an explanation question, then it has to be clear and it has to be detailed. Okay, so that's what you're looking for. So even if you write a couple of bits and you try to explain it, you're going to get 2 marks, okay, or 1 or 2 marks. If you then start to use some science in there, a bit more science in there, and you're explaining it, that's going to give you a maximum of 4 marks. If you do it really clear in detail, which is what we're looking for, that's going to get you the 6 marks. Okay, so I'm just trying to help you. Then bandings are always very similar. A couple of things that that you're writing are trying to explain, even if it's not quite right, it's still going to get you 2 marks. 4 marks, you're using some science in there. 6 marks, it's really clear and really detailed. That's kind of how it works every time. So I'm going to let you do that question. Okay, so use that graph now that you've got drawn and explain it. You can write on the graph, write around it, and use some explanations about forces, etc. This is normal exam practice, so 6 minutes to try and do those 6 marks. Off you go. Okay, you've got 1 more minute left. Okay, so these are the answers or the type of. So this is the type of thing that you should have come up with. So when the person jumps out of the airplane, then the force acting is weight and that acts downwards. As the parachutist falls, air resistance increases because they are going faster, and then weight is greater than the air resistance. So they're the first couple of bits that you need to talk about, and then you need to say these two forces, weight and air resistance, eventually will even out and become balanced. So then the parachutist comes into terminal velocity. On the second part of the graph, the parachutist will open the parachute. That increases the surface area, which increases the air resistance. The air resistance is then greater than the weight, which means then they decelerate, and then eventually air resistance and weight become equal, and it's a new lower terminal velocity. So we've talked about the forces and we've done it clearly. That would give you the 6 marks. So if you are making some revision cards or you want a brief key points to this lesson, always good to have these written down somewhere. Usually a revision card's better. Then these are the main points from the lesson. So terminal velocity happens when a falling object falls at the same velocity, and that's because the air resistance and the weight are equal. So remember, when forces are equal, the object is either stationary because it was already stationary, or it falls at the or moves at the same speed, and that's all that's happening here. Weight and air resistance have become equal, so it falls at the same speed. It's just got a different name, and that's called terminal velocity. A parachute will slow down a skydiver because it increases air resistance. It's got a much larger area, so more air particles will hit it. But eventually weight and air resistance will become equal, so now the parachute will hit terminal velocity again. It's just a much slower terminal velocity, which means that it's safer to hit the ground. And I mentioned before about fluids, this is on the specification as well, but it's the same idea. So the same thing would occur in a fluid, but the terminal velocity would be much lower because there is more drag in this case. So air resistance won't happen in a fluid, obviously, but there's more drag, which means then that it would be a lot slower, the terminal velocity. I would always have this graph drawn, even if it's a sketch graph with some bits written around it. So I'll leave this on for another 5 minutes just so you've got that down. And then very well done, guys. If you are at home or you're in lesson, you're doing an absolutely fantastic job. I'll give you 5 minutes, but if you need to pause this, then please pause it. Off you go.